Okay, so for this session, I was designated to talk about multiplying fractions, and I have a presentation that covers both. So if there's time, I am happy to go over both adding and multiplying fractions. So let's jump in. I have a presentation prepared, but then I also think it's easier just to see some examples and work through some problems. Just me writing some problems out and sharing the results here. So I'll go through some slides on the presentation and then I'll jump out of the presentation and go through some examples. So let me get my screen share here going on. Okay. Okay, let me jump in here. Okay, so adding and multiplying fractions. To start, let's just take a step back before we get into the math part of things and just think about what is a fraction. When I hear the word fraction, I think sometimes people think, they seem scary, but fractions are not scary. You deal with them in everyday life. Fraction simply means it's a part of a whole. So if I have 50 cents in my pocket and I ask, well, what fraction or what piece of a dollar is 50 cents? Because I know that it takes 50 cents is half of $1, a simple fraction. If I look at another example, an inch is a fraction of a foot, right? So if I'm measuring something and I say, well, this is, let's say 3 inches. Well, 3 inches is the piece that I'm looking at, and the foot is the whole. So the fraction is 3 out of 12 because I know that there are 12 inches in a foot. Same thing if we're looking at days in a week. If I'm looking at what fraction of the entire week, so the entire week is 7 days, is Monday through Friday. So I know Monday through Friday is 5 days, so that's the piece, and 7 days is the totality of the week. So the piece, the 5, goes in the numerator, which is the top, and then 7, the whole, is the denominator, the bottom, right? So think top, numerator, bottom, denominator. So on this screen, I don't think I need to walk through all of these, but these are a few additional examples of fractions. And, for example, if I were to look at this pizza, right, and I say, I'm going to snag the pepperoni piece. Well, then if I asked, well, what fraction of the whole pizza did I take when I took the pepperoni piece and ate it? So in order to identify what that one piece of pepperoni is out of the whole, I have to know how many pieces are in the whole. So I count the pizza and I know that there are 1, 2, 3, 4, 5, 6, 7, 8. So by taking that one piece of pepperoni, I have taken 1/8, 1/8. So we have a couple more examples here. Again, with thinking about a foot, if I look at a foot and I know it has 12 inches and I want to know what 5 inches is, if I want to write that as a fraction, I would put 5 in the numerator over 12. 5 is the piece that I'm looking at and 12 is the whole. 47 cents is what fraction of a dollar? Well, you put the 47 over 100, you get your piece of the whole. So the 47 cents is the piece, the $1 is the whole. Another example, a pound contains 16 ounces. So I would think, okay, and the question is, what 9 ounces is what fraction or what piece of the overall pound? and I know there's 16 ounces in a pound, and the piece that I'm looking at is 9 ounces. So 9 is the fraction, 16 is the top part of the fraction, it's the piece that I'm looking for, and then 16 is the denominator. And we'll get there, but if I have 9 over 16, I can definitely simplify that fraction into simpler terms. So we'll talk about that in a little bit as well. And here are just 2 more examples for you to think about. 7 months, what fraction of a year? How many months in a year? We know there's 12, so 7 over 12. 8 cents is what fraction of a quarter? How would I write that fraction? I would put the 8 in the numerator in the top, and I would put the quarter, 25, in the bottom. So 8 over 25. So we have a couple different types of fractions that you'll run into, and I wanted to review the terminology just so that everybody's comfortable with it, because we'll see this when we start doing addition and multiplication. When you think about a proper fraction, that means that the top, the piece, is less than the whole, the bottom. Couple examples here: 1/3, 3 over 10, 7 over 20. We can clearly see that the top is less than the bottom, so the part is less than the whole. Now, an improper fraction is when the top, the numerator, is greater than the denominator. So what we eventually have to do is we have to end up making that a mixed number. And a mixed number is a number that has a whole number and a fraction with it. So if you look at this example right here at the bottom of the page, 1 1/3, so I have the 1 whole, and then I have the fraction of 1/3, is ultimately the same as 1 plus 1/3. Look at another example here, 2 2/5. So I have the whole number of 2, and then I have 2/5 as the fraction. So when we look at that and we break it down, it's the same as taking that whole number of 2 and adding 2/5, the fraction, to it. And that's going to become important when we look at adding fractions, especially adding mixed numbers together. When you think about a fraction, we've already said that it's a piece of a whole, right? And that a proper fraction has a numerator that's smaller than the denominator. An improper fraction is the reverse of that. The numerator is greater than the denominator. But if we're looking at fractions and we're trying to estimate what's the size of the fraction, is it a half? Is it less than a half? Or is it greater than a half? This is helping us estimate, do some estimations. So when I look at this example right here, I've given 4 different fractions: 2 over 4, 5 over 10, 10 over 20, and 15 over 30. Now, what's interesting is, even though these are different numbers because they have different numerators and different denominators, which you can see very clearly that they're all different fractions, but they all simplify down to the same number, and that number is 1/2. So 2 is half of 4, 5 is half of 10, 10 is half of 20, and 15 is half of 30. Now, how do I know when I'm looking at a fraction if it's greater, if it's a half? I can identify it because I can simplify the fraction down, right? So 2 over 4, I divided the numerator and the denominator by 2 to reduce it to 1/2. I did the exact same thing with 5 over 10. I took the 5 and the 10, and I said both of these numbers are divisible by 5. So I divided 5 by 5, which gave me 1. I divided 10 by 5, which gave me 2. I did the same thing with 10 over 20 and 15 over 30. Now, when we're looking at a fraction that's less than half, you can identify that by first, what I do when I see a fraction is identify where would the halfway point be. And then is the numerator greater or less than that halfway point? So I'll take a look at this 3/8 here. So if I look at 3/8 and I'm trying to figure out, is 3/8, is it more than half? Is it half? Or is it less than half? So right away, I think, well, what is exactly 1/2? If that fraction was 4/8, I would be able to divide both the numerator and the denominator by 4, which would give me 1/2. So 3 is less than 4. Okay, so I make the conclusion that this is less than half. Let's do the same type of process on the next example, on the third bullet point, where it says a fraction is greater than 1/2 when the numerator is more than half the denominator. So same process applies. I'll look at this 6/10, just to pick one example. So if I look at 6/10 and I'm thinking, is that more than half? Is that less than half? I know that the halfway point, that fraction that gets me to half, is 5/10, right? Because 5 is halfway to 10. So knowing that 6 is greater than 5, I can say, aha, if 5/10 is a half, this is greater than a half. So these exercises, thinking about what's half, what's greater than half, and less than half, is really important as we think through the size of fractions, and especially when you end up doing some estimations of when we start getting into calculating and doing addition and subtraction as well as multiplication and division. But we won't cover all of that today. So this page, I just listed out a few examples of getting a fraction down to its simplest terms, right? So whenever you do a math problem, especially with fractions, you want to get the fraction down to its simplest term. And we do that by identifying if there is a number that we can divide both the numerator and the denominator by that reduces the fraction to its simplest term. So if I'm looking at 4/8, I know that I can divide both of those by 2. Well, I could divide by 2, but I could also divide right away by 4. Divide the numerator by 4 and the denominator by 4, which gives me 1/2. Same thing with the 5/10. I look at that fraction, I think that's not in its simplest terms. I need to get it to its lowest terms. So what is the number that I can divide both the numerator by and the denominator by to get me to my simplest terms? And that number is 5 in this second example of 5/10. So I divide the 5 by 5, which gives me 1. And I divide the 10 by 5, which gives me 2. So it gives me 1/2. Okay. I am actually going to jump here because I know that we are talking about multiplying fractions, and multiplying fractions are actually easier than adding fractions. So I'm going to start with that, and then if we have time in the lesson, we can go back and look at adding fractions together. So multiplying fractions essentially means that you're finding a fraction of a fraction. And when I hear the word fraction, immediately I want to think piece. So I'm finding a piece of a piece already. We know what a whole number is, right? A whole number is 2 or 4 or 10 or 20. But a fraction, a piece, would be 2/10 or 5/20, right? So if I'm multiplying two pieces together, I know that the answer is going to be smaller. And now this is when we're working with proper fractions, okay? That's when fractions have the lower number in the numerator. That's a proper fraction. When I have two proper fractions and I'm multiplying them together, I know that the product is going to be smaller than the two fractions I'm multiplying together. And the product is the answer, okay? And the reason that is because I'm looking for a piece of an existing piece. And so that piece is going to be smaller. Okay, multiplying fractions, the fun part about multiplying fractions is that you do not need to find a common denominator. We'll talk about that when we do addition of fractions, but when you're multiplying fractions, you don't need to find a common denominator because it's a very simple two-step process. If I'm looking at these two fractions here, 4/5 times 2/3. I like to set this up as, and I didn't do it in this case, so I think I'm going to take my presentation down and just write this out how I like to write it out, because I think it's easier when I write it out this way and I'm going through the steps. So I'm going to stop sharing my screen for a second. I'm going to jump into, okay. So in this case, I like to write that problem out like this. 4/5 times 2/3. And what I do in this case is I end up multiplying the numerator by the numerator and the denominator by the denominator. So when I rewrite the fraction, 4/5 times 2/3 is the same as 4 times 2 in the numerator and 5 times 3 in the denominator. So I've simply taken the numerators and multiplied them by each other, and the denominators and multiplied them by each other. And then I've rewritten the fraction just to illustrate exactly what I said. I think for me, it's easier to conceptualize when I see it written out like this. So I know that it's numerator times numerator over denominator times denominator. So I'm going to do that math, and I'm ultimately going to get my final answer of 8/15. Now, that was a good example, but let me give another example here just so you guys can see. I'm going to do 1/2 times 2/3. Okay. So 1/2 times 2/3. So I'm going to go through the exact same process. I'm going to take the numerators and multiply them. I'm going to multiply 1 by 2, and then I'm going to take the denominators and multiply them. So I'm going to write it out just so you can see my steps and my process here. 1/2, 1 times 2 over 2 times 3. So that's what I want my formula to look like. That's just, again, so I can conceptualize numerator times numerator, denominator times denominator. And when I do that, I end up getting 2/6. Hopefully you guys can see these. 2/6. Now that answer is correct, but again, I want to think about simplifying, because if I leave it at 2/6, it's correct, but I can still take it down farther. And what does that mean? If I take that 2/6, this is simplifying, which becomes really important when we multiply fractions. And I'll teach you a trick of how to simplify before you multiply. So if I take that 2/6 and I think of what number can I divide both the numerator and the denominator by to simplify, so I take that 2/6, and I know that I have to simplify it because I know that I can divide both the numerator and the denominator by 2 to get me to my final answer, which is 1/3. Okay, let's try another example here. I've got 2/3 times 4/5. Okay, this is the example I'm working with. 2/3 times 4/5. So I'm going to do the exact same thing. I'm going to rewrite the equation just so that I remember that it's 2 times 4 over 3. You know what? Let me make that 4 over 6 to shake it up a little bit. I'm going to do 2 over 3 times 4 over 6. We'll give this a little bit of a different answer here. So that equals 2 times 4 over 3 times 6. So here I've taken the two fractions, and when I need to multiply them together, I multiply the numerators. So I multiply the 2 and the 4, and then I multiply the denominators, the 3 and the 6. And again, I like to rewrite it just so that I remember it's numerator times numerator, denominator times denominator. So when I go ahead and do this math, 2 times 4 is 8, and 3 times 6 is 18. Okay, so I get 8 over 18. And I know that I can reduce that, but I have to figure out what number can I divide both the 8 and the 18 by to get a smaller fraction in its simplest terms. Okay, so here is what I'm going to do. I'm going to show you two ways to do this. So I know that they are both divisible by 2. So if I divide the 8 by 2 and the 18 by 2, I get 4 over 9. Okay, so that's my simplification process. Divided both the numerator and the denominator by 2. And that got me to my final simplified answer of 4 over 9. Now, what if I could get to that answer faster through the problem? Well, here is a trick. It's not really a trick, it's really about cross-canceling. But I'll show you what you can do. So if I have that 2 over 3 times 4 over 6, what I can do is before I even start multiplying, I can do cancellations. So, try to get my papers here, bear with me. That's into the sun, so there's no way you're going to see that. Okay, so I have my two fractions here. I could just multiply the 2 to the 4 like we just did and got my 8, and 3 times 6, got my 18 down here. But what I can do is I can cross cancel within the fractions before I do any multiplication to get the fractions to their simplest terms so that when I multiply, I'm already at the simplest fraction. So I don't have to think about reducing the fraction. Okay, so how do I do that? I simply look across. So I look at the 3 and the 4, and I think, is there any number that I could divide both the 3 and the 4 by that would get them to a simpler term? No, I can divide 4 by 2, but I can't divide 3 by 2, so that doesn't work. I could divide 3 by 3, but I can't divide 4 by 3, so that doesn't work. But what about the 2 and the 6? Well, in this case, I know that they are both divisible by 2. So if I take the 2 divided by 2, I get 1. If I get the 6 divided by 2, I get 3. So then, when I do my multiplication, okay, I'm multiplying numerator by numerator, denominator by denominator. But my new numerator, since I've simplified, and my new denominator since I've simplified. So I get 1 times 4 over 3 times 3. 1 times 4 over 3 times 3, which gets us to our final answer of 4 over 9, which is the exact same answer we got when we did the problem the other way. But I think this is just so much easier because ultimately what it does is it allows you to reduce the fractions before you do the multiplication. So it gets you to that simple term answer a little bit faster. Okay, let's look at another problem here. Okay, so this is a good one because I think this shows how many steps it might take to simplify a very big problem. So let me give you an example. If I have 6 over 11 times 7 over 8. Okay, that's my problem. Six over 11 times 7 over 8. So I know that I'm multiplying the numerators. So I'm multiplying, so I'm going to rewrite the problem. 6 times 7 over 11 times 8. Okay, that's my same problem, just I've rewritten it so that I know that I'm multiplying numerator by numerator, denominator by denominator. So when I look at this math problem here, I'm thinking, okay, 6 times 7, I know that one, that's 30. I'm sorry, that's 42. And 11 times 8 is 88, okay? So I'm looking at this 42 over 88, and I'm thinking, wow, I'm definitely going to need to simplify that. And it might take me a few minutes to figure out what is a common number that I can use to divide both the 42 and the 88 to get it in its simplest terms. So this is a great opportunity to use the cross cancellation, because here what we'll be able to do is we'll be able to look across the fraction and see if we can simplify it before we do multiplication. So in this case, okay, I'm looking at the 7 and 11 because I always look across, and I think, well, there's really nothing I can divide both the 7 and the 11 by to simplify it, so that's not going to work. But what about the 6 and the 8? Is there a number that I can divide both the 6 and the 8 by to get them in their simplest terms? And so the answer is yes. I can divide the 6 and the 8 by 2, which gives me 3 and 4. So my problem just went from 6 times 7 over 11 times 8. Now I've reduced the 6 to a 3. So my numerator part of the problem will be 3 times 7. And I've reduced the 8 to a 4. So my denominator part of the problem will be 4 times 11. So if I write that out, my 3 times 7 over 11 times 4 equals 3 times 7 over 11 times 4. So that became this problem. Okay, the 3 times 7 over 11 times 4, rewritten so that the 3 and the 7 are in the numerator, the 11 and the 4 are the denominator. Then I do my math and I work out that 3 times 7 is 21 and 11 times 4 is 44. Which is my answer in simplest terms. Now remember, when we did the original problem, we ended up with 42 over 88. And if I divide, not very good at keeping these straight, thanks for bearing with me here. If I divide the 42 and the 88, both the numerator and the denominator, by 2, I get this answer, 21 over 44. So I just got there quicker before I ended up doing the multiplication. Okay, let's look at another example here. Okay. So I'm gonna do a 4/6 times 3/8. All right. So here's my next example. 4/6 times 3/8. So what I first want to think about is my cross cancellation before I start doing any multiplication, right? And I'm thinking, all right, I'm looking across at the 4 and the 8, and I'm hoping there's something that I can divide both the 4 and the 8 by, because I'm going across from the 4 to the 8. Okay, 4 to 8. What can I divide both of these numbers by to simplify them? Well, I know that I can divide 4 by 4, and that gives me 1. And I can divide 8 by 4, and that gives me 2. So I'm gonna cross those numbers out, and I'm gonna write my 1, and I'm gonna write my 2 here. So those are my new numbers that I'm working with because I divided the 4 and the 8 by a common number, which took it down, divided the 4 by 4, which got me 1, and I divided the 8 by 4, which got me 2. So now that I've got that pair, right, because again, we're looking across the 4 and the 8, now I get to look at the other cross pair, the 6 and the 3, okay? So then I think, well, what can I divide the 6 and the 3 by, if anything, to get these numbers in their simplest terms? Okay, well, I know that 3 goes into 6 2 times, so I can divide 3 by 3, which gives me 1, and I can divide 6 by 3, which gives me 2. So I'm going to write those new numbers down there. Okay, so now I've crossed out all the numbers and replaced them with their simplified fractions. So at this point, now what's next to do is multiply numerator by numerator, denominator by denominator. So I'm going to rewrite the fraction because I think when you simplify, you have so many numbers because you've crossed numbers out. So it's easier just to rewrite it to make sure that you know what you're multiplying. So this becomes my new fraction, okay? 1 times 1 over 2 times 2, which is 1 over 4. Now we would have gotten the same answer had we done the original multiplication problem that we had at the very beginning and multiplied 3 times 4 and 6 times 8. But here's what we would have had to do. We would have had to, instead of simplifying, we would have had to take the 3 times 4 and the 6 times 8. And we would have had to create that fraction. So we have our 6 times 8 in our denominator, right? So this was our fraction, our original. 3 times 4 over 6 times 8. So 3 times 4 would give us 12. 6 times 8, 48. But then we think, oh my goodness, I'm gonna have to reduce that because I know there's something that I can divide both the numerator by and the denominator by to get that fraction into its simplest form. And so this is where it's going to take me a little bit of time to think about this. But ultimately, what that fraction ends up getting reduced to, I'll just show you the math quickly here, is you end up dividing the numerator and the denominator by 12 to get to our final answer of 1/4. So I think, in my perspective, you can't go wrong either way. You can either divide, you can either multiply and then reduce when you get your answer, but I think it's easier to cross cancel as soon as you see your fraction and your equation there, because then you're ultimately multiplying smaller numbers and you know it's going to be in its simplest terms. So let's think about one other scenario. We've been doing 2 fractions, but what do I do if I have 3 fractions? All right. So in this case, I have 3. I'm multiplying 3 fractions together. And it doesn't matter if I have 2 fractions to multiply, 3 fractions, 4, 5, 6. It doesn't matter how many different fractions are in this equation. I'm still following the exact same principle as I did with the 2 fractions, right? I'm still multiplying all the numerators by all the denominators. So in this case, I would take all the numerators. I would take 1 times 2 times 6. Carry that down to the denominator. I would do the 3 times 3 times 8. Okay. Well, if I just look at this, I think, okay, 1 times 2, and I wrote that out, right? It's always good just to practice writing it out in the format, just so we remember that it's numerators multiplied by numerators, denominators multiplied by denominators. So this is then what our equation looks like. Well, I can tell right from just looking at this equation that it's going to be a fairly sizable number, right? Because I'm multiplying 1 times 2 is 2, 2 times 6 is 12, but then I have to multiply the denominator, which is 3 times 3, right? So 9, and then 9 times 8, which is 72. So now I've got this big fraction of 12 over 72. And I think it's going to be much easier if we look at our cross canceling before we do our multiplication. So in this case, I look across all 3 of the fractions and I try to find ways where I can simplify. Okay, so if I look at this first one, I look from 1 to 3. Now I can't really do anything there. That's really as small as it goes. Even the 2 to 3. Nope, there's nothing I can divide both the 2 and the 3 by that gets it in its simplest terms. So there's nothing I could do there. Let's look at this fraction here, these 2. Well, if I look at the 3 and the 6, I know that both of them are divisible by 3, so I can cancel the 3 out, put a 1 there. I can cancel the 6 out. I can't write upside down. And put a 2 there. So I've already reduced that. But now what about the 2 and the 8? I know that both, I can divide 2 by 2. Okay, paper's falling all over the place. I can divide 2 by 2, and that gives me 1. And I can divide 8 by 2, and that gives me 4. So let me write those down. So that I cross out the 2, and I put a 1, and I cross out the 8, and I put a 4. Okay, so now our multiplication becomes, I think, a little bit easier than that 1 times 2 times 6 over 3 times 3 times 8. So it now becomes 1 times 1 times 2 over 3 times 1 times 4. Okay, so that's our simplified equation, and I like that better because the numbers are smaller. So for me, it's just easier to multiply smaller numbers in my head faster. So if I do the multiplication across, remember I'm multiplying the numerator, the numbers in the numerator, and then multiplying the numbers in the denominator. So 1 times 1 times 2 is 2. And 1 times 3 is 3, and 3 times 4 is 12. So now in this case, I can actually reduce it one step further and get it down to 2 1 over 6. Okay, so that's how we cross multiply and simplify, or we cross simplify rather. Let's look at just one more problem here. 1 over 2 times 4 over 3 times 3 over 5. Okay. So now if we were doing this problem as is, I would multiply all the numerators together. I would multiply 1 times 4 times 3, and then I would multiply all the denominators together. 2 times 3 times 5. So if I do that math across, I get 12 over 30. Okay. I had to do a little bit of, do some thinking on that one. I had to do a couple steps to get my 1 times 4, and then my 3 times 4 is 12, and 2 times 3 is 6. And then I had to remember that 6 times 5 is 30. So if I can simplify this and make it easier on myself before I do the multiplication, I'm definitely going to do that. So if I'm looking at this problem, and I'm wondering where I might be able to cross cancel. Well, I know I can take the 3 and the 3, same number, so I can divide them by themselves. 3 divided by 3, 1. 3 divided by 3, 1. I can't do anything here with the 4 and the 5. That's not going to simplify anywhere. But I can definitely do something with this 4 and the 2. So I'm going to simplify the 2 to 1. I'm going to take the 4, because I essentially just divided 2 by 2, which got me the 1. I'm going to take this 4 and divide by 2 to get me the 2. So now my problem becomes 1 times 2 times 1 over 1 times 1 times 5. Okay, I like doing that math a lot easier than doing the math that we had in the top, because the numbers are smaller. So it's easier for me to do 1 times 2, which is 2, times 1, which is 2. And then if I look at the denominator, I know 1 times 1 is 1, and 1 times 5 is 5. So then my answer gets me down here to 2 over 5. Okay, now again, you can do it either way, but I think it's so much easier to do our cancellations here before up here, before doing all this complicated multiplication, so that we're left with a multiplication problem that's just a little bit simpler. So that is cross canceling. And I have one more thing to mention about multiplying. I'm sorry we didn't get to adding fractions, but we can do that in another section. So sometimes what you're going to see is a combination of a whole number and a fraction. So if I'm given a problem like this, okay. So if I'm given a problem like this, which is basically multiplying whole numbers and fractions, right? That 9 is my whole number, and that 5/6 is my fraction. So I think, okay, Well, what do I do here? My first step is to turn this whole number, this 9, into a fraction. And I can always do that by putting it over 1. Because essentially any number over 1 is itself, so you can always make it into a fraction by taking the number and putting it over 1. So now I have the problem 9 over 1 times 5 over 6. So the problem turns into a multiplication of 2 fractions simply by placing the 9 over 1 to give me a fraction, and I multiply it by 5 over 6. Now again, I want to avoid as much as possible doing some difficult multiplication, so I'm going to look in this problem and see if I can cross cancel, okay? So I look at my 5 and my 1, and I know that there's nothing I can do there because 1's as low as it's going to go, but I can definitely divide my 9 and my 6 by something, right? So if I divide my 9 and my 6 by 3, okay, so that's what it looks like. I did my cross canceling and I divided both my 9 and my 6. So I divided 9 by 3, which gave me 3. And then I divided my 6 by 3, which gave me my 2. So then when I do the multiplication, 3 times 5 is 15. And 1 times 2 is 2. So I can tell immediately right here that because my 15, my numerator, is bigger than my 2, I've got an improper fraction. So I'm going to have to turn this into a mixed number. So if I take my 15 over 2, okay, I can't leave it like that because the numerator is greater than the denominator, which means it's an improper fraction. And so I know that there's a mixed number in here and I have to figure out what it is. Well, if I take 2 times 7, I know that's 14. So I know 2 goes, because I'm trying to figure out how many times does 2 go into 15? What number of times does 2 go into 15? What whole number can I get 2 to go into 15? And the answer is 2 times 7, right? Because if I have 2 times 7, I pull out my 7 as my whole number, because 2 times 7 is 14, and then I have 1 left over, and that's my 1/2. So 15 over 2 is the same thing when I change it from an improper fraction to a mixed number as 7 and 1/2. Now, if I want to check my math to see if I did this correctly, in order to change this mixed number back into a proper fraction to check my math, I take the 2 and the 7 and I multiply and I add 1. So 2 times 7 is 14 plus 1 is 15 over 2. Okay, let's try one more because I know that that's if I have 4, because there are a couple steps there, 4 and 1/2 times 5 over 6. Okay, so in this case, I have a mixed number. The 4 1/2 is the mixed number, and the 5 6 is the fraction. So in order to multiply these out, I need to turn the mixed number, the 4 1/2, into an improper fraction so that I can multiply it by my 5 6. Okay, and I turn my 4 1/2 into an improper fraction by multiplying the 2 times the 4 and adding the 1. So what this mixed number becomes is 2 times 4 is 8 plus 1. 9 over 2 times 5 over 6. Nine over 2 is the same thing as 4 1/2. So I've converted the mixed number to an improper fraction. And now that I've done that, now that I have both numbers in fraction form, okay, without mixed numbers, now I can do my cross canceling, okay? So I look at my 5 and my 2, and there's nothing that's divisible by both. I can divide 2 by 2, but I can't divide 5 by 2, so I'm going to leave those there. But I can definitely divide 9 and 6 by 3. So if I divide the 9 by 3, I get 3. If I divide the 6 by 3, I get 2. So now I've simplified my multiplication equation, and I'm going to multiply 3 times 5 and 2 times 2. So 3 times 5 is 15 over 4. Okay? So I know immediately that this is an improper fraction because my numerator, the 15, is greater than the denominator. So I have to turn this into a mixed number. So if I've got 15 over 4, I'm thinking, how many times can 4 go into 15? Well, let's start doing my multiplication tables. If I put 4 times 2, that gives me 8. Well, that goes into 15, but then there's still a lot left over because 15 minus 8, there's still something I can multiply the 4 by to get me closer to the 15. I want to get as close as possible. So if I multiply the 4 by 4, I get 16, which is too much. But if I multiply the 4 by 3, I get 12. So this number becomes, I pull the 3 out as the whole number, and then I look at my leftovers. So 15 minus 12 is 3, and that is my fraction. So this improper fraction of 15 over 4 is the same thing as the mixed number of 3 and 3/4. And to check my math, just to make sure I did that correctly, I multiply to turn this number back into an improper fraction. I multiply the 3 and the 4 times 12, plus 3 is 15 over 4. So I know that these are equal. Okay, that is multiplying fractions. I hope that was helpful. I think multiplying fractions, because we don't need to find a common denominator like we do in adding fractions. We simply multiply the numerators by the numerators and the denominators by the denominators. And that's the same whether we have 2 fractions in the equation, 3, 4, 10, 20. You're still multiplying all the numerators across and all the denominators. But don't forget to cross cancel so that you can get your fractions into their lowest terms, so that when you multiply, you're not multiplying super high numbers to get a very high end product. You reduce by cross canceling so that the multiplication is a little bit easier to get to your final product. Thanks so much.